Hi dear students and viewers, welcome back to our channel. Dear students, we are entered into the chapter of oscillations now. In that chapter, first short answer we are going to discuss. It's very important, and this concept is helpful to the remaining all questions in the chapter. Okay, that's why you have to watch it very carefully. What is mean by simple harmonic motion and give examples? That is the question. What is mean by simple harmonic motion? So dear students, already we have idea about the translatory motion or linear motion. What is mean by translatory motion? If the position of the body is changes with respect to time along the line, straight line, that should be called linear motion or translatory motion. Clear? In previous chapter we discussed what it is the rotational motion. If a body is rotating about one axis, one fixed axis, that should be what we call rotatory motion. And now here we have another one, it is there, that is the periodic motion. What is mean by periodic motion? If the same type of motion can be repeated, that is called periodic motion. The motion itself be repeated. For example, once you can switch on the fan, the wings of the fan is continuously, it makes so many revolutions. Every time its motion should be like one revolution. And rotation of wheels of the bus, here it is the periodic motion. Clear? The motion of a body repeated itself, that should be what we call periodic motion. Translatory motion means motion of the body along a straight line, and rotatory motion means what? The body can rotate with respect of one fixed axis. And third one is what? And periodic motion is what it is, the same type of motion is repeated, that is what we call periodic motion. You can, for example, I am taking this pen, now I am shaking like this, now it is the periodic motion, and this is also periodic motion. Clear? Like that. So now coming to the point here, what is mean by simple harmonic motion? If a body or a particle is said to be in simple harmonic motion, that should be consists of three conditions. That should be going to be satisfied three conditions. The first thing is the motion of the body should be oscillatory, like to and fro motion. That's the first thing. And the second thing is the acceleration of the particle is directly proportional to its displacement, but in opposite direction. Clear? And third one is the acceleration is always towards mean point or mean position. That should be called simple harmonic motion. If a particle can satisfy the three conditions, the first thing is what, children? The body must be or particle must be consist of to and fro motion. And second thing is what? Acceleration is directly proportional to the displacement, but in opposite direction. And third one is what? Acceleration is always towards mean position. That is called simple harmonic motion. When these three conditions are satisfied, then what you have to say? The particle must be in simple harmonic motion. For example, children, here this is a 1 point, that is I am saying 0, mean position. I am saying this is the mean position. From this point to particle is moving forward and again comes back, again goes this direction. Clear? So it is going in forward direction, again that should be coming to the back again. So at every time that should be crosses the mean position. That is like a swing. We are taking some swing, it is there. It is the mean position. It goes to be extreme position like this and comes like this. Clear? One swing it is there, initially it is rest, that is the mean position, and we are pulling the swing to the one side and we are leaving it, then it can exhibit the oscillations. So at every time it can crosses its mean position. Clear? So this is the mean position we are saying. the body is moving this direction and again comes back and again goes this direction. Again, same thing. At every time it can crosses its mean position. That is what you have to say, oscillatory motion or simple harmonic motion. Here every time crosses the mean position, and what you are saying, acceleration is directly proportional to the displacement. Now we are writing A is proportional to minus x. What is A? Acceleration of the particle, and what is x? Displacement. How these two are indirectly proportional. Here minus represents the opposite direction. Clear? And third one is the velocity, what it is changes, due to that some acceleration is produced. The acceleration is always towards mean position. So this is about this, children, simply simple harmonic motion. Here you have to observe simple harmonic motion, also called as oscillatory motion. Oscillatory motion is a periodic motion. Clear? Oscillatory motion is a periodic motion, but every periodic motion is not oscillatory. Clear? Oscillatory motion is a periodic motion. Why? Because it is the mean position and this particle is moving this direction and again this direction, again this direction, this direction. It means that what? It is repeating itself. The motion is repeated. That's why it is periodic motion, but it is oscillatory. But every periodic motion is not oscillatory. For example, wings of the fan are in rotatory motion. Here that is the periodic motion, but it is not oscillatory motion. That's why you have to understand the difference between oscillatory motion and periodic motion. So now children, we can go for examples. Examples of simple harmonic motion. The first thing is, when we are consider some simple pendulum, the oscillations made by the simple pendulum with little amplitude, they can be taken as examples for simple harmonic motion. It means that children, simple pendulum is nothing but certain mass is suspended with help of a massless string. Now it is called a simple pendulum. It is called simple pendulum. So now it is a simple pendulum. A body of certain mass that should be suspended with the help of massless string like this. Now it is called a simple pendulum. If you can pull the bob one side and you can leave it, then that will execute the simple harmonic motions like this. So it will execute like this. So those are examples for simple harmonic motion. And next thing is oscillations of a loaded spring. This is also one of the best example for simple harmonic motion. So children, it is a one spring. For the lower end we are attaching some mass. Clear? Now it is called a loaded spring. What it is called? Loaded spring. We can hold the mass and little bit and pull it downwards. We are holding mass and we are pulling it downwards and simply leaving that. Then it will execute the simple harmonic oscillations. That's why this is also example for simple harmonic motion. And similarly, vibrations of liquid in U-shaped tube. For example, now it is the one U-shaped tube. In that, up to here some water is there. Clear? One U-shaped tube it is there. In that some liquid is there. Now simply if you can raise one limb, the water should be displaced to the other side. And if you can raise this one, moves like this. So the liquid what it is in the pipe, that should be goes like this, like a swing. Those also oscillations also called examples for simple harmonic motion. And next thing is motion of atoms in solids and cork floating on water. These are also example for SHM. Cork floating on water. When we are taking some steady water, in that you can drop any cork. It will execute the S like this. To fro along the mean position. So children, these are the examples for SHM. So it's enough for 4 marks, I think so. If you can understand this one, like, share, comment the video. Children, in our channel we have all the videos of intermediate first year, second year along with the MSET NEET. So that's why how to subscribe my channel and follow my channel regularly. Thank you for watching.